So before we go and discuss shaft wall liner systems, this is kind of the idea that I'm talking about in this kind of mass timber brace system. Just a couple of images here. Um, and, you know, I actually think I created this project. This is UMass. I actually presented a paper there, but the project was developed actually before even visiting this project. But I did use some of the imagery. One of the most compelling ones was how beautiful this room looks with a kind of mass timber system. And I can imagine this kind of cross bracing. We're making a much simplified version of it in our family element. You can see behind it a gypsum board surface, which could be that shaft wall liner I'm discussing. And I'll just point out in the next couple of tabs here that I have open in Chrome. So this is just a really beautiful project at the University of Massachusetts. And they house their architecture department here. So it's a really, really cool space. So now on that idea of shaft wall liner, obviously with any through cuts on all floor systems, this is a path for fire. And I don't know how this was discussed in codes or other training. So if I'm repeating myself, I would apologize. But the idea that these chimney type areas like stairwells and elevator cores are pathways for fire to spread through buildings, and so they need extra special attention in the prevention of fire spreading around them. And many times, a lot of that is because is just inherent in the kind of materials they're created with, and because they're used as shear walls. They usually can be made out of concrete or heavy masonry construction with reinforcing in it. But as we look towards reducing carbon in our building construction, this idea of using other materials that are more environmental, and I think really the big issue on environmental impact is the removal of cement, which has a heavy carbon footprint to it. So this concept of shaft wall liners has really been around a long time. I used to consult for literally 30 years ago for National Gypsum, and I was a research test engineer, and as I probably mentioned before. But we used to deal with shaft wall liner. It was a product of National Gypsum at the time. And shaft wall liner is really gypsum board that's just extra thick. And because it's extra thick, it's really massively heavy. It's like carrying 2 sheets of gypsum board. So one of the ideas in the creation of shaft wall liner is to also make it, the panels are typically 2 feet instead of 4 feet wide. And another thing that goes on with these are rated assemblies, and it would be very difficult to get fasteners to hold securely through that, and not destroy the integrity of that gypsum board in that fire-rated assembly. So typically what happens is they're mechanically coupled together with a channel of metal that holds them in place. And I'm actually not sure how that metal doesn't create a problem with distorting or other failure, other than each panel is next to each other. So any kind of distortion in the metal would have very little effect because they're kind of like stacked up on top of each other. Anyway, so that's very typical in shaft wall liners that they have this H channel separating them. Let's see if I have a better image of that. So that's just shaft wall liner. And area separation walls, 2-hour ratings, cavity shafts 1 to 4. And many times that extra rating comes from another level of gypsum board. So here's 2 1-inch thick, 2-inch thick assembly with an H channel between it. That would be used in that kind of a shaft liner. And so, and when I say shaft, it also could be a stairwell or some other kind of vertical element within a building that might need fire ratings. And so here's a cavity wall that would be a typical type of construction. So here we have, we're looking at a cross section here, and we're looking at a special kind of metal stud that has the integrated H-clip and the steel stud, so that you can build up both the rated gypsum board and then apply another gypsum board layer on that. And then you can actually continue to improve the performance of that cavity by adding more gypsum board to it. So this is just a very typical technique of the way we would create fire-rated assemblies for these kind of applications.